This video will walk you through ANOVA analysis examples. So the first one that we are going to do is a single factor ANOVA. We're doing this using the SAT scores data. This can be found under review questions for chapter 13, that data set. It's actually question number 26 in your textbook. Scholastic aptitude test contains 3 parts: a critical reading, mathematics, and writing portion. Each part is scored at an 800-point scale. Information on test scores for the 2009 version of the SATs is available on the College Board's website. A sample of SAT scores for the following 6 students is as follows, and we have the data there. Use a 5% level of significance to determine whether students perform differently on the 3 portions. Which portion of the test seems to give the students the most trouble? Explain. So we want to know, is there a difference in the scores on the 3 different types of tests here? So the factors are the scores, the treatments are the individual tests, and the experimental unit are these 6 students. So I'm going to go into data, data analysis, select, scroll up here, select single factor ANOVA, click OK. My input range, right here, are those scores. I do have labels in my first row. My data is grouped by columns. Since we have column, my data is grouped in columns, not grouped by student. It's since I'm concerned with whether or not there is a difference in the 3 tests, I have to group it by columns. My output, I want to put this here on this same worksheet. I'll put the answer right there and click OK. All right, so I have a lot of information on here, but the only thing I really care about is going to be this p-value right here. And this p-value is not less than 0.05. Therefore, I do not reject HO. Now, my HO is that my HO is the equality of the 3 populations. So my HO is that my tests, I have equal scores on each of the 3 tests, and I can see that since I do not reject HO, that yes, a student does seem to perform fairly consistently across the 3 different tests. So I am 95% confident that students perform roughly the same on the 3 portions of the test. If I want to see which portion seems to give students the most trouble, I can look here at the averages up top, and the average score on writing tends to be the lowest, but it's not statistically significantly different from the others. The next example that we are going to look at is a 2-factor without replication, and that is actually number 42 in your textbook, and that is using the rents data set. So here, the U.S. Department of Housing and Urban Development provides data that show the fair market monthly rent for metropolitan areas. The following data show the fair market monthly rent in 2005 for 1, 2, and 3 bedroom apartments in 5 metropolitan areas. At a 5% level of significance, test whether the mean fair market value of rent is the same in each of the metropolitan areas. So here, I have 2 different factors in play. I have the number of bedrooms and also the metropolitan area, both of which I think would logically impact rent. I mean, obviously, real estate prices are different in different cities. We can see just by looking at this that Miami seems to be a whole lot cheaper than, say, Boston or Washington. Miami seems to be cheaper than anywhere, honestly. And then we would think logically, obviously, a 1-bedroom must be cheaper than a 3-bedroom. So we have those 2 factors that we're going to take into account. So I'm going to go to data, data analysis, 2-factor without replication, click OK. I input all of this data here. I do have labels. Okay, and my output range, notice I have to click on there, otherwise it's going to undo all my work. I'll just put that right there. Click OK. All right, so how do I interpret this? I'm looking at my p-values. Both p-values are less than 0.05. So my hypothesis, when I'm doing this, I'm testing the equality of 3 or more populations. 3 or more population means after both factors have been taken into account. And I can look at my p-values here, and I see that in both cases I would reject HO. So HO is that the metropolitan area has no impact on price. In other words, the average monthly rent would be the same in each of those metropolitan areas. So I'm rejecting that idea. So there is a statistically significant difference in the metropolitan areas as well. I'm sorry, I'm looking at the columns right here, which is the metropolitan areas. I can also say, based on the rows, since that is also less than 0.05, that there is a statistically significant difference in monthly rents for 1 versus 2 versus 3 bedrooms. So in both cases, I'm rejecting HO. So even after I have taken municipal or metropolitan area into account, there's still a statistically significant difference in rents based on the number of bedrooms that you have, and I can reverse that as well. I can also say even after the number of bedrooms have been taken into account, there is still a statistically significant difference in rents in my metropolitan areas. And then I can look on here and see, obviously, yes, the average for a 3-bedroom does tend to be highest. And then I can look here on my averages, and average rent tends to be slightly more expensive in San Diego than in other locations.